Okay, now we'll look at the different types of solutions you could get for a system of linear equations. Okay, so let's go back to the two equations, two unknowns situation. These are lines in the plane in R2. And if you think about it, let's look at this first question here. How many different ways can you arrange two lines? Well, we could have two lines that intersect at a point, two lines that are parallel, and the third example is two lines that are parallel and overlap. Okay, those are three different ways two lines in two-dimensional space can be arranged. Now let's look at, we'll put that aside, and we'll look at these systems now. Okay, I'm going to write these as coefficient matrices, like this. And I could try to solve this, and I'll just do the calculations now in front of you, just so you can see how I do them. You can work on them on your own, see if you would do them in the same way. So I have 5 minus 5. 2 minus 5 times 2, give me minus 8. And then 1 minus 5 times 1, minus 4. Okay. And 1, 2, and 1. Now I'll add, I'll divide the first one actually by 4. I'll take this and I'll times it by 1/4. Let's make it negative 1/4. So then I would have 2 here and 1 over here. Okay. Down here I've got 1, 2, 1. Now you can see why I did that, why I chose to multiply the first row by negative 1/4. These middle coefficients are going to line up. Okay. So I can subtract 1 from the first row from the second. And you know what? I'll also multiply the first row by 1/2 just to make this a 1. So I've got 0, 1, 1/2. Second row, I've got 1 minus 0. And what I'm doing here, I did multiple operations at the same time. I'm saying here that I'm going to subtract this second row from the second row, the first row, as it stands over here. Okay, so it's going to be 2 minus 2, so 0, and then 1 minus 1, it's going to give me 0 as well. Then, just to put a bow on it, I'll switch the rows around. I got 1, 0, 0, and then 0, 1, 1/2. Okay, I can reinterpret these in terms of the systems of equations, and I've got x equals whatever variable is here in that third position, it's 0, and then y is equal to 1/2. Okay. Now if we think about this, if we just go back to that first question for a second, each of these is a line in 2 dimensions. And then I got this as a solution. So what this tells me is these two lines, they intersect. I don't know what they look like exactly. Doesn't really matter. What it's saying here is that these two lines intersect, and the point they intersect at is 0, 1/2. Okay? Try graphing these on Desmos and see what I mean, how these two lines intersect exactly at one point. Okay, now let's continue with that. Let's do this one here. I'm going to write this as coefficient matrix. I've got 3 minus 1 in the second position. Sorry, that was a little close. And then 2, and then 1 minus 1/3, and 0. Oh, okay, I can see what I should do here. I'll I'll subtract, or no, I'll multiply the first row by 1/3. Sorry, I was thinking about something. There's just all the different ways that we could possibly do this. This was my first thought, but then I had a second thought to do it slightly different. And ultimately, it doesn't really matter. You just choose something and you run with it. Okay, this worked out pretty well because now these coefficients line up and I can subtract row 2 from row 1. What that's going to end up with is this. Got 0, 0, and then 2/3 minus 0, so that gives me 2/3. Then the second row I didn't do anything to. Leave it like this. Okay, now let's reinterpret that as a system of equations. So let's look at the second one. Well, actually, you know what I'll do is, I'll rearrange it like this, and I'll write down this second row in terms of an equation right now. I've got x minus 1/3 equals, or 1/3 y equals 0. And then the top one, well, my coefficient on my x is 0. The coefficient on my y is 0. So I have 0 on the left-hand side equals 2/3. Well, that's not good. That's inconsistent. I can't have 2/3 equal to 0. So this is an example of these equations not having a solution. It's an inconsistent system. Okay? It's not a surprise that it is inconsistent. If I had multiplied this whole thing by 3, you see what I have is 3x minus y equals 2, and 3x minus y equals 0. If you think about this, these are two different lines, but they have the same slope. So they're two parallel lines. They don't intersect anywhere. Okay? If they don't intersect anywhere, then there's no x and y values that are on both lines at the same time. Okay? It has no solution. Okay? There's no x and y, to reword this, there's no x and y that will satisfy both of those equations at the same time. Okay? This is an example, our first example of a system that has no solution. Okay, now if you look down here at the bottom, we kind of suspect something's going to go on here because it looks like, I got a coefficient of 1 here, a coefficient of 1 here, -3, -3. It seems pretty similar. So let's write it as some coefficient matrix. -3 for x, -3 for y, and then 3. Now I'm going to multiply that second row by -1/3. That gives me 1, 1, minus 1, and 1, 1, minus 1. If I subtract that row 2 from row 1, then what I'm left with is 1, oops, sorry, I wanted to subtract it from the first one from the second one. Otherwise, I'd have to flip the rows afterwards. Doesn't really matter. You could do that and then do it, then flip them if you wanted to. But now if we look at this, if we were to reinterpret this in terms of our systems of equations, I'd have x plus y equals -1, and then 0 equals 0. Well, that doesn't add anything to the conversation. But if we look at that first one, what is that? Well, that's an equation for a line. So there's an infinite number of solutions. There's an infinite number of x's and y's that satisfy both of these equations at the same time, so long as x plus y equals -1. So we have another situation. This situation was that We had two parallel lines that didn't intersect. This one is that these two are actually the same line. So any x and y that satisfies this equation will also satisfy that second equation. There's an infinite number of solutions. Okay, so these are the three ways of arranging lines in two-dimensional space. You could have two that intersect somewhere, two that are parallel, or two that overlap. And that's it. Those are all possible cases. And that gives you three different types of solutions to these linear equations. Now we can kick this up a notch and look at 3 dimensions. Things change a bit, right? What are these the equations for? Well, each one's an equation for a plane. So I want you to think about how many different ways are there to arrange planes in 3-dimensional space. And that's something we'll take up in person. Okay, so just to wrap things up here, we have really just 3 possibilities when we work with a coefficient matrix and we reduce it all the way down, try to get to that row reduced echelon form. If we do get to that row reduced echelon form, we know we have exactly one solution. It's going to be a point xy or xyz or something like this. If we can't get down there, then there's 2 possibilities. Either we have infinitely many solutions or we have no solution at all. Okay? So those are our 3 possibilities. We'll look at the infinitely many case and the no solution case next time.